Good morning to one and all gathered here. We're here to attend the webinar. We're here to attend the webinar conducted by Department of Civil Engineering, Global Practices in Civil Engineering, Foundation Options for Expansive Soils in Middle Eastern Countries by Mr. Araz Ahmed Hamza. Welcome, Mr.
Thank you.
I hope you have a wonderful session. I hand it over to Ms. Dr. Vandana Devi, our HOD, to introduce our guest for today.
Good morning. Good morning to one and all gathered here. It's my privilege to welcome our expert speaker, Mr. Araz Ahmed Hamza, lecturer, University of Raparin, Kurdistan, Iraq, for today's webinar on global practices in civil engineering, foundation options for expansive soils in Middle East countries. Welcome, sir.
Thank you very much. Thank you.
I extend my warm welcome to my dear students and faculty members for today's webinar. First of all, let me tell you how we chose this topic. Expansive soils pose problems to civil engineers in general and to all the geotechnical engineers in particular. Most of our students are employed in Middle Eastern countries, and the expansive soils are also present in our country as well. So our budding civil engineers must know how to deal with the damages of expansive soils, the remedial and treatment solutions to deal with expansive problems, and hence this webinar. As I said, expansive soil is a worldwide problematic soil that causes extensive damage to the civil engineering structures. They cause damage to structures founded in them because of their potential to react to changes in the moisture regime. These soils undergo severe volume changes corresponding to changes in the moisture content. As you all know, from the term expansive soil, they swell or increase in their volume when they imbibe water and shrink or reduce in their volume on evaporation of water. This is the concept behind expansive soils. Because of their alternate swelling and shrinkage, they result in detrimental cracking of lightly loaded civil engineering structures such as foundations, retaining walls, pavements, and airports, sidewalks, canal beds, and even canal linings. We have documented evidence about the existence of problems associated with expansive clays have occurred in countries like India, Africa, Australia, United States of America, Middle Eastern countries, and in Canada. Expansive soils are also known as swelling soils, heaving soils, and volume-changing soils. Their physical characteristics mostly include low bearing capacity, high settlement, low shear strength, and high water absorbability. So it's very challenging for any civil engineer to lay the foundation on expansive soils. That's what I'm trying to say. The low bearing capacity of expansive soils creates problems in civil engineering structures, whereas their water content is high and responsible for consolidation settlements in cases of loaded grounds. In addition, their low shear and compressive strength usually results in shear failure, which is a very big problem for any civil engineer to attack. Such soils are considered as natural hazards, as told by an IIT professor, and they pose severe challenges to any civil engineer. Hence, to throw light on the challenges caused by expansive soils on the civil engineering structures, we have invited an expert in foundation engineering, Mr. Araz Ahmed Hamza, from University of Raparin, Kurdistan region of Iraq. Now, it's time to introduce the expert to my dear students and faculty members. Mr. Araz Ahmed Hamza is a lecturer at the University of Raparin in the Civil Engineering Department, Iraq, Kurdistan. Meanwhile, he is working as a consultant engineer with local municipality. He obtained his bachelor's degree in 2008 at the University of Sulaimani, Iraq. After graduation, he worked as a civil engineer and acted as a site engineer, executing and monitoring more than 20 civil engineering projects. Later, he went to Cyprus for pursuing his postgraduate studies and obtained his master's degree in civil engineering from Eastern Mediterranean University in the year 2016. Then, he has worked as an assistant lecturer at the University of Raparin. During his professional experience, he has taught various professional courses like, to name a few, environmental engineering, engineering geology, soil mechanics, drawings, like engineering drawing, and descriptive geometry and foundation engineering. Mr. Araz Ahmed Hamza has published many research papers in the local and international journals in the fields of solid waste management and foundation engineering. He is also a member of Kurdistan Engineers Union. With this short note, I once again welcome Mr. Araz Ahmed Hamza to this webinar. Thank you so much. Over to you, sir.
Thank you very much. Thank you very much, dear students, dear audience, and special thanks for KCG College of Technology and especially Civil Engineering Department for having me for this online session. And special thanks for Professor Dr. Van Han Devi for your effort that you have done for managing this online session. Thank you all and welcome. I think it's not need to introduce myself. Thank you very much for your nice speech, for remarkable words regarding to introducing me. Shortly, my name is Araz and I'm a lecturer at the University of Raparin. Hopefully I accept this invitation from the KCG University to talk about expansive soil, because as Professor said, this is a very challenging subject for the civil engineer. This is a very problematic types of soil that make a problem for every type of project in different places. Now, in order to save time, let me share my screen and start the presentation. Could you see the slide, please?
Yes, sir, it is visible.
Okay, thank you very much. Okay, again, good morning, everybody, ladies and gentlemen. I'm going to talk about the foundation options for expansive soil in Middle East country during 40 minutes, and then we will provide 20 minutes for discussion. And if you have any question, you can keep your question for the end of the seminar. Well, I prepared my seminar according to this outline. In this time, I'm going to talk about such topics regarding to expansive soil, soil and site investigation is very briefly to know what is this process. And we are talking about the general soil problems. And among the problems, we focused on expansive soil. Then we define this type of soil and give some background about, and then we focus on the problems of expansive soil for construction. And we are talking about the soil, this expansive soil distribution in the world and identification, how we can identify this type of soil. And then we are talking about the damages of expansive soil. And after we define it, after we know which type of soil is, we are, as a civil engineer, we need to think about solve this problem, because this is our duty as an engineer to solve such a problem. Then we try to explain how we can treat this type of soil, which type of solution we can use in order to control such a problem that comes from expansive soil. And we are going to talk about some different strategies that can be used for prevention of those damages that comes from such a problematic soil, and we have conclusion. Now, let's start from site investigation. For engineers and the students from civil engineering, it's very important to know about site investigation. What is site investigation? When you are talking, if you have a plan for constructing every project in every place, before everything, we need to have some information about the land, because we are going to use that land to construct our project, how we can do it. This is the process which named site investigation, is the process of determining the layers of natural soil deposits that we are using for our structure. It means this is the main requirement for every project. In that level, or I mean, in this step, we required to identify the soil. We are, as a civil engineer, and most specifically the geotechnical engineers, should go to such a site and identify, is there any soil problem or not? Why soil problem is very important? Or let me ask another question for the students. Why soil is main course for you? Why soil is main topic for civil engineer? Very shortly, the answer is because soil has a vital role in every project, because we have 3 different levels for soil. We have lots of projects that constructed in soil, inside the soil, like the foundation, like the tunnels, like the trench, every pipe, different types of pipe. It means that a large number of projects can be constructed inside the soil. Also, we have some other projects that constructed off soil. It means that the soil is the main material that can be used for constructing such a project, like embankments, like the earth dam, and the different layers of under the pavement. These are the structures that constructed from soil, off soil. That's why the soil is very important. And we need to remember that every project that in your mind as an engineer constructed on soil, it means that we have a good relation with the soil. We cannot, we are not required to do not think about the soil, because the construction process may be faced to the a large different types of problem if you don't care about the soil. Therefore, we need to think about the soil properly in the first stage of the project with the site investigation. I'm not going to go to the detail of that site investigation, because this is not our subject, but this is important to the students and the engineers to know that in that level, we need to find and identify the different problems of soil. During the site investigation, you can feel such a problems regarding the soil. But dear students, please be informed that when you are searching for problematic soil, there are 2 main branches for problems regarding to soil. Some of problems go to the agriculture purpose, and some others go to the construction purpose. You are a civil engineer, please be informed that focus on the soil problematic regarding to construction, not for agriculture purpose. Well, if you look at the main problems of soil regarding to construction, there are many different types of problem, but there are some powerful ones: collapsible soil, dispersive soil, and expansive soil. Collapsible soil and dispersive soil, these are some different types of soil that because of some different minerals inside the soil, they are faced to settlements and landsliding, such like this. Again, I'm not going to go to the detail of such a problem, but today's seminar is about expansive soil. This is the main problem of soil, and this is the main topic of our webinar. What is expansive soil? Now it's time to define this type of soil. According to the different research and the different experts from soil mechanics, there are different types of definition for soil. For example, Nielsen and Miller said the concept of expansive soil can be utilized for describing soils which include a significant amount of variation in volume because of exchange the amount of the soil water content. Also, we have another definition: expansive soil are the soils that have potential for swelling and shrinking under change moisture condition. Another definition, plastic clays termed as expansive soil or active soil exhibit volume change when subjected to the moisture variation. You see, we have different type of definition, but all the different types, if maybe there are lots of definition for expansive soil, but there's two keywords in all different definition. I know you are, as a student, you can define expansive soil again, but be careful about two things. This is the mechanism of swelling. We should say this type of soil that tendency to volume change. Volume change is the main phenomena in the expansive soil. What is the reason behind of this volume change is water content, moisture content. That is all about the expansive soil. Now, simply we can understand or redefine it in the very simple shape, which expansive soil are soils that expand. It means swell when water is added and shrink when they dry out. It means there's a large amount of volume change due to water. If there is water, it expands, and if there is no water, shrink. That's the definition of expansive soil. In India, expansive soil is known as black cotton soil that can be identified in the central of India in some different places, and generally it covers 30 to 40% of the land area of India. It means that the expansive soil is the challenge for the civil engineers in India. This is the specific definition and there's some backgrounds about expansive soil. But if we ask why there is two main phenomena in expansive soil, one of them volume change and the second one is water content. Because expansive soil contains such minerals that tendency to expand, like montmorillonite, illite, kaolinite. These are the main clay content inside the expansive soil that make it expand in wet season and shrink in dry season. Annually, many damages due to swelling behavior expansive soil have been noted, obviously in where? In arid and semi-arid zones. Why? Because we said that the water content variation make this change or make the expansive soil be active. That's why the arid and semi-arid zone, the zones that are faced to such a problem, and mostly it can be damaged, have a damage for pavement, foundation of structure, highway, water line, reservoir, every light project. What about the volume, the size of the damage? According to Jones and Holtz that they recorded in 1973, the cost for damage was 2.3 billion of USA dollars. And also Jones again recorded that this cost increased dramatically to 9 billion in 1987. This is the main cost that used or spent just for damage of expansive soil. This is the only data that I collected from the USA. And this price or this damages cost may be more than this in some other different countries, but it's not recorded. As most specifically in undeveloped country, if there is no good researcher, or if there is no a good engineering system to deal with such a problem, you cannot get the accurate data. Now, what are the problems of expansive soil for construction? We said that it is a very problematic and it is a challenge for civil engineer. What are those problems and how we can deal with them? Now, sorry, there is a technical problem. This slide cannot change it. Okay. Can see the slide, please?
Yes, sir. Yes, sir.
Oh, okay. Thank you very much. What are the problems? The expansive soil has considerable strength in dry state. It means that if the expansive soil is dry, it has a strength, is enough strength that can bearing the load. But the strength goes on reducing on the absorption of the water, and the considerable pressure on the foundation will be produced during the swelling. This is the problem for construction. If the land is dry, that time you can say is very good land for constructing the project. But if it is expansive soil, that cannot be depend on it, because in the wet season, it faces to the swelling. This is the main problem for construction. When expansive soil are present, they will generally not cause a problem if the water content is remain constant. Again, as we said, if it is dry, it has a good strength. Also, if there is no change in water, the water, if it's stable, also maybe there is no problem. But in case there is a water variation, it can damage to the construction. That's the main idea for engineers to think about how this type of soil make a problem for construction. Expansive soil usually will not have a problem with heavy structure, but with a light structure and pavement is very dangerous. This is another key success for thinking style for engineers. If you have a heavy structure, there is no doubt in specifying a place which is expansive soil. But in case you have a lightweight structure, you should think about and aware for how to construct your structure, because the expansive soil can damage the lightweight structure. The volume of expansive soil can increase up to 10% of its volume during the swelling. And the force that the expansive soil can produce maybe vary according to the clay content between 480 kilopound to 1,440 kilopound, according to the size and the range of the clay content inside. This is a huge pressure that they can produce for our structure. Now, what are the main factors behind of expansion of expansive soil? We said that expansive soil doesn't have problem if there is no change in volume. Now there's a question, why this type of soil is changed? Because there are some factors make the soil to expansion. The first factor is change in water content. How this change will occur? This is very important for the engineers or the site engineers to control such a places or such a situation that make the variation of the water content. The first one is rain, that's out of our control. Just we need to think about. And the weather is important, and your country is important. If there's a full season, or if there's the high variation temperature during the dry season to wet season, that's the problem. This is the one of the methods that make the change water content inside the expansive soil. Another one, garden watering creates a moisture zone on the exterior of foundation. It is important for you as a civil engineer to think about this, especially when you design your house, your home. Please be careful about the around your project, because if you plant trees near to your foundation, it leads to watering the soil, and then the problem will occur. Cesspool, septic tanks, leakage of pipe, and swimming pool. If you have any of this type of project, when you are a site engineer, please be careful about such a problem. Do not let the leakage, do not allow anyone to have such a problem, or water goes to such a places behind or beside of your foundation. Why? Because it leads to the big problem, just like those crackers that you see in the picture. This would be because of water variation in the soil beneath of your foundation. That's the first factor behind of volume change. The second factor behind of volume change is amount of clay size particle. We say that why expansive soil is tendency to expand, because the clay mineral. It means that if the land that you dedicated for your project had a large amount of clay content or silt content, it means that there is a tendency for expansion. Why? Because the expansive soil consists of some clay minerals. Therefore, you should have a sieve analysis for the land that you decide to use for your project. If there is a clay content, it means that you should care about the expansive soil. And type of clay of particle also, which type of clay minerals are in your clay content. That's the second deal for you. If there is a large amount of clay content in your sample, then you should think about which type of clay mineral, because as we mentioned before, if it is colonite, elnite, montmorillonite, these type of minerals has a tendency for expand. Why? Because the most popular soil cation are. This is the cation exchange capacity. Why those type of minerals has such a situation? Because they can extract the water. Why they can do it? This is the chemical reaction, because they have a high cation exchange capacity. That is an advanced subject. I'm not going to detail of this problem, but this is the engineering answer for expansive soil. Why expansive soil expand? Because of clay mineral. Which type of clay mineral? Montmorillonite is the ones that has a vital role. Why? Because it has a high cation exchange capacity between 80 to 120. The cation exchange capacity means that they have this type of mineral, hydrogens, sodium and calcium, magnesium, potassium, and ammonium, that they tendency to extract the water. And when they get it water, they expand. And when they face it to the dry season, they, by the evaporation process, the water goes and the volume will remain, and then the settlement occurred. This settlement also caused to the cracking on your foundation, on your wall, on your structure. That's the idea behind of expansive soil. Okay, we talked about expansive soil definition. We give it a good background about the expansive soil and their damage, and we explained why this type of soil has a problem for construction. And also we explained the causes behind of this expansion. Now we need to know about the distribution of expansive soil in the wall, how it is distributed. Actually, there is no accurate map to show us the distribution of expansive soil, because the only developed country could deal with such a problem. they could collect data, they could provide a good map for their country. This is the good requirement for the engineers in every country in the world. Please do this, because this is very important for your construction industry to have a specific map that show the different location of your country, that there is tendency of what? Of expansive soil. The only countries that showed their data are USA, Burma, Canada, Spain, South Africa, Mexico, Israel, Turkey, and some other Middle East countries, Iran, Ghana, and Argentina, Cuba, Ethiopia, Morocco, and India. And also, regarding to the volume or the level of expansive soil, because expansive soil, again, can be categorized to some level: high swelling potential, low swelling potential, and medium swelling potential. The red color represent the high swelling potential in those countries, and the blue less than 50. And you can see these, the colors arranged according to the level of expansive potentiality. If there is a red color, it means that those type of countries should think about the expansive soil, because this is the serious problem for their construction industry. Hope to every country has a specific map for that. Unfortunately, I couldn't find any specific map for the Middle East, because, as I said, this belongs to your how you deal with it, how you work it on it. You should have a specific system to collect such a data, to do research, to identify different places of your location, city to city, and inside the city, place to place. And then you collect all those data in one map for your country, and then you can put your map on the world map. The only thing that I found regarding to Middle is the soil grain types in the Middle East. As you can see, there is some data that show the clay content, or show the type of soil. If you look at the silt and clay in the region 1, this covered the Syria and a part of Iraq and Jordan. It means that there's silt and clay. If you remember, I said, if the soil contains silt and clay, it means that there's a possibility for the problem. But now you need to deal with it more, because the clay content does not mean that the 100% is expansive soil. You should go to through the mineral composition. If the minerals are the montmorillonite, that means that expansive soil. And the other countries, we have a fine sand and medium sand for the Saudi Arabia and some parts of Egypt. It means that there is no problem. But this is not accurate data. This is not accurate map, because we need accurate map for having such a data. This is the only thing that I got it from the internet for distribution of the expansive soil in the world. Now, for you as a civil engineer, how you identify the expansive soil? Because in the future, maybe you have some different project in the different city, in the different country. How you feel, how you can decide about the expansive soil? There are some methods that can be used to identify the expansive soil. The first method is visual identification of expansive soil. This is very important for every engineer, especially for the expert engineer, to feel the expansive soil by visualize. How? There are some symptoms regarding to the expansive soil area. The first one, during the dry season, the shrinkage crowd can be observed easily. The soil seems rock hard when it's dried, but it is very adhesive and soft when it's wet. Always there are damage on the nearby building because of expansive soil. Those type of symptoms will help you to identify that such a area maybe is expansive soil area. Also, there are some other methods that earlier in the past used, and also today is also is available and possible to use them to identify the expansive soil by dealing with the engineering behavior of the soil, like grain size, properties of the soil texture. For example, the atabalic limit, liquid limit and plastic limit can be a very good parameter to identify or decide about the expansive soil. For example, there's some different persons that use atabalic limit for identify the expansive soil, Holtz and Gibbs and Chen, and also you have IS standard. According to the plasticity index, if the plasticity index, for example, is less than 20, the Holtz and Gibbs state that this is the low expansive soil. But if it is more than 32, means that sample or that land is very high expansive soil. That's why you are, as a civil engineer, also you're required to take a sample and go to the lab, do the atabalic limit. If you found the plasticity index is high, that time you should care about the location. It is an expansive soil. Again, US Army in 1980 used the plasticity index to identify the expansive soil. You can use the liquid limit, plasticity index to find the potential swell and the potential classification. And also Sitharan and Praksh also used some different parameters of soil to find the expansive soil. For example, the content of colloids, shrinkage limit, shrinkage index, free swell test, and the percent expansion in odometer test that can be done in our lab. Those are experiment, and the parameters can be used to identify the expansive soil. How the expansive soil damage our project? According to the geotechnical engineering evaluation, we said that the mostly lightweight structure undergo damage of expansive soil. And there is some mechanism of having or occurring such a damage. The mechanism is, there is two types of mechanism that use it to apply it for implement it for the project. Or this is the method that expansive soil can damage, how the short-term effect and long-term effect. How the damage will occur by both methods. The first one, what does short-term effect means? The first picture explains the short-term effect. It means that in the short time, our new project may be damaged. How? For example, we constructed this project in dry season and wet season followed. If you look at the picture, you see we already constructed in dry season. It means that the location or the soil in the shrinkage state, and then by wetting season, the water comes to the beside of the foundation, and the soil beneath the foundation, because they took the water and they changed the water content and they swell. You see, the edge has swelled and they push it and they want to uplift the structure. Therefore, there's the crack, and this phenomenon known edge heave condition mean there is the heaving in the edge of the building. Why? Because the building constructed in dry season and the wet season comes followed. And this phenomena is the short-term effect. In contrast, if the project constructed in the wet season, the lands already swell. We put our project on it, and the dry season followed. When the dry season comes, because of evaporation process, the water inside the expansive soil comes out and the settlement will occur. This phenomena known as shrink effect. Why? Because the sun effect couldn't affect on the center of the project of the building, but can change the water content beside your building. This is the second phenomena with name edge shrink effect. Both phenomena can be nominated as the short-term effect. What about the long-term effect? the moisture content continuously increases inside under the beneath of your foundation by what? By the capillary action. Why? Because we always have the water content variation because of the rain and the other causes that we discussed. It means that by the capillary action, the water extracted to the center of the foundation. When the water comes to the saturate or the level that needs to, the chemical reaction starts, the process, the swelling process will start at the center of the foundation. But in the edge of the foundation, because we have the change variation in the weathering, they will dry and shrink. And this is lead to unequilibrium water content under the foundation. It means that there's no homogeneous water content beneath your foundation. That time, as you can see, at the center of the foundation, there's a swelling, and the edge of the foundation, we have the shrinkage. This is the edge shrink and center have condition phenomenon, and also nominate as the long-term effect of expansive soil on our project. Okay, now it's time to try to solve this problem. The civil engineer is your responsibility to think about the problem, because the problem solution is our duty. How we can try to find a solution for such a problem? There's two options that we should think about. The first option is soil treatment. We need to make some treatment process for the soil. This is the first option that we can do it. And the second option is strengthen the structure or change the design. Make the design a specific design for our project that can sustain or undergo these variation, this volume change variation of the soil. How this is the costly. We need to think about different types of foundation. We need to strengthen the materials, everything. Now, I would like to focus on the first option, which is the soil treatment. How we can treat the soil, because the second option is already discussed and we can do it as a structural engineer, and I'm focusing in the next slide by adding some strategy. Now, how we can treat the soil, which is the first option. And for you as a civil engineer, it's required to think about the first option, which is the soil treatment, because this is not costly if you compare with the structural variation. The first technique that can be used to soil treatment is the replacing the expansive soil under the foundation. This is the first and very simple method that uses to remove and replace those soil. But we can use this technique in case there is a thin layer of expansive soil. If there is a thick layer, if there is a depth, high depth of expansive soil, it's not applicable. This is one of the techniques that be used for soil treatment. The second technique that can be used for soil treatment is changing the nature of the expansive soil. Changing the nature. How we can change the nature of the soil? By some different activity or techniques. The first one, compaction, pre-wetting, installation of moisture barrier, or stabilization process. Okay, now let's talk about the one by one. Compaction. We can compact the soil to change the soil nature or the structure of the soil. By the compaction process, we can increase the density of the soil. We can reduce the amount of air voids inside the soil. That's why this is one of the techniques that can be used to reduce the height of the soil. This is one of the techniques that can be used to change the nature of expansive soil. The second one is pre-wetting. Pre-wetting means you have a specific land that you have planned to construct a project, but this is the expansive soil. You can pre-wet it to swell. If you fill water on in such a land, like a ponding, they extracted the water and they tried to swell. But this process is a very low process because of the soil capillarity. That's why it's not very practicable for engineering purpose. But in some cases, we can use an added 4 to 5% of hydrated lime in order to speed up the reactions, and soil started to heaving, and then you constructed the project on this heaving, and then cannot be have a pressure on your project. This is another method that used, which is named ponding or pre-wetting. Installation of moisture barriers. If you remember, we said that the main reason is the water content or water variation. How? By the two different effects. We said that there's a short-term effect and long-term effect. How those effects, how these mechanisms work? By the capillary of the water, by the extracting water to the beneath of your foundation. If you have a tendency to install such a material, that is the impervious material that do not the water to pass through it, that time you can isolate your foundation, and you can keep the water content variation, the stable water content beneath the foundation, and it will be okay because there is no water change or water variation in the soil. This will be very good technique, and the technique also can be used by the trench filled with the gravel, lean concrete, or impervious barriers, everything by compacting. You can think about this, how you implement this idea. It is up to you which type of material do you use, but the main idea is to isolate your foundation from the outside the water. The last technique that used for changing the nature of the soil is soil stabilization. What is soil stabilization? For the ones who want to research in the future, you will face to such a topic in the geotechnical area. Soil stabilization is the very wide area in the research for regarding soil. What is this process? It is the geotechnical process targeting of improving the one or more mechanical and chemical soil characteristics so as to improve their engineering characteristics. How can be done? What was this process? By adding some different material or by implementing some activity. We can categorize the soil stabilization for two main branches. The first one is mechanical stabilization or chemical stabilization. The mechanical stabilization, already discussed, it includes all these things: remove and replacement, compaction, pre-wetting, moisture barrier, every mechanical action that we can do to stabilize the soils. It means to enhance the soil, enhance some properties of the soil. We already discussed this, but what about the chemical stabilization? The chemical stabilization is another process that can be done to enhance some properties of the soil by adding some different material that can react with the clay content, react with the clay particles and their tendency to change variation or cure the variation in their properties. But be careful that in the practical implementation of such a technique is not very easy. It's somehow difficult. It can be implemented for the depth of 1 to 1.5 meter. If the expansive soil is its depth is higher than 1.5 is not possible. Even for 1 to 1.5 is not very practicable, because in the research area is very common, but I think in the practical is not common. How we can do this? How we can practice or implement the chemical stabilization? By adding such materials. What are these materials? We can add the lime, hydrated lime. We can add fly ash. We can add cement, burned brick, marble, gasoline, and rice husk ash, silica fume. All these materials or different materials can be mixed with the expansive soil, and they tendency to reduce the swelling potential and the level of swelling. Also, scrap tire, rubber, and plastic, another material. Why I green is the scrap tire rubber, because this is the subject that I use it in my master. I stabilize the expansive soil by using the plastic from the tire recycling. This is the good material that can be used, and it has two functions for environmental function and also the geotechnical function. But generally, the process is not easy in practical. Now, regarding to the second option, this is the end of the first option that we said we need to treatment for the soil. Now, if you could not treatment the soil, we can do something else for the structure. There are some technique, there are some hint notes that the engineers should follow to keep their structure. The one of them is controlling water access to the soil. This is a very simple method, but it's valuable for your structure. Try to control the water access, because the water is the main reason behind of this change. Ground surface slope away from the structure. If you look at those pictures, the first picture, the problem, and the second one is solution. There is some area around your project. Please try to make a slope in this area in order to the water comes away, goes away from your structures, not come to benefit of your structures. This is a very simple for civil engineer. They can do it. If you do not do it, you see that they have a great impact on your structure. Draining rainfall sufficiently from away from the foundation. Water from the rain and the roof water. In the first picture, you see the water freely comes to beside your foundation and goes to the beneath of your foundation. 100% they affect your foundation. If you found any structure around your home, around your institute, if there is a crack, just look at this. There is some area around the project that water can go beneath the foundation easily. Therefore, it's very good to manage properly by piping and try to make away from your structure. Not placing landscaping that will require extensive water, as we explained in the tree, plant, grasses, not to be close to your structure, because they need water, and the water percolated to the soil, and then the water content variation will happen inside the beneath your foundation. Another technique that we think is altering the method of construction. You are a civil engineer, should think about the methods or the construction process, how you constructed such a project, because according to the expert, according to the research, the shallow foundation, separate footing, raft mat foundation, basement of all are those type of elements of foundation that undergo the expansive soil problems. Therefore, in case you have such a project, you should think about and you should manage it properly. Another strategies that can be employed for the foundation are what? Passing the expansive soil. How you can pass the expansive soil layer? By implement the deep foundation. If you have a deep layer of expansive soil, sometimes you can pass this layer by constructing the deep footing. At that time, you can keep your structure from the active zone, which is the expansive soil, and cannot hit and face your structure. Another technique, another finding that can be used, implemented in the foundation, the most probably in the shallow foundation, is the waffled foundation. This is a new technique. This is this has a good response for foundation problem on the expansive soil. What is the waffle foundation? You see that if you have combined footing, if you have a continuous wall footing or raft footing, you can provide a void area beneath your foundation. This space provided for what? For the volume change of the soil. When the soil wetted, we said that expanded, and this expansion make a pressure on the beneath of your foundation. But if there is such a hole inside the foundation, that time we will be safe from that effect, that pressure, because they go to such a void, and it will be okay for our foundation, and there is no settlement and there is no shrinkage, because the soil cannot contact it with the foundation. The waffle foundation is one of the most important and powerful technique for expansive soil, and I will show you a video how to implement this and how it works. Also, the waffle foundation can be used by the different material. Plastic material can be used, the boxes, the flint, and in some cases you can use the degradable materials, the like cardboard, because the cardboard can stand by the fresh concrete, but the fresh concrete after it's dried and it's not need to be supported by such a material, and the material when get wetted and try to degrade, and then the void, the space that we need will be provided for the variation change in the volume of the soil, and this will be a very good technique for soil movement and soil improvement. Another strategy is for the basement wall, because the expansive soil can affect every structure. It has the soil pressure in both direction, in the vertical direction and the horizontal direction. In the horizontal direction, if we backfilling, use the material of soil, expansive soil material for the backfilling, then it leads to the pressure, mega pressure on the wall. As you can see, this is the horizontal crack as occurring in this soil, in this wall, because of the expansive soil. What is the strategy? Try to use different material. Try to use different material with non-expansive material. And also in some developed countries, they use plastic, granular plastic, to fill such a project or the backfilling process. Why? Because the plastic or any other materials that they lightweight, and they do not make a pressure on the wall, and also they are not expansive. This is another idea for backfilling. And that's the end of my presentation, and I would like to, in conclusion, recap some main points regarding to the subject. The main point and the outcome of this subject is the expansive soil are very problematic during the construction of foundation. This is the very simple sentence, but it's very valuable for engineers to think about. Foundation on expansive soil is what was the problem? Again, we repeated, and also we should repeat in your mind that all the problems of expansive soil comes from moisture content. And even the Terzaghi said, if there is no water on the earth plan, we don't need the soil mechanic. It means that all problems of soil, different problems of soil, comes from the water. Water is very valuable in our daily life, but is very problematic for the soil. Therefore, we need to think about the control the water variation. This is the main idea for every engineer to be safe from the expansive soil. It is possible to build successfully and safely project on expansive soil. For the engineers, it is not possible. You cannot say I can't construct the project on that land, because the land use is valuable. We should think about the land, you see, because the land is limited on the earth. That's why we can construct successfully such project. But how the project be successful on expansive soil? By dealing with some other things, by stable moisture content and some other techniques that we discussed. The process for success also testing, identifying, dealing with. You should deal with the subject. If there is expansive soil, you need to care about. That's the whole idea. The construction process of foundation must be controlled by the engineers. This is another technique, another thing, another key success for your project. That's not enough to say, I have a good plan and I have a good design, No, you should have a good construction process as well, because the paper is not enough. The process on the side is important. There are different solution options for controlling the problem. For you as a civil engineer, there is no single way to deal with fixing the problem. There are lots of options that you think about, and you are free to which method do you use according to your environment and your situation. And this is the reference. And thank you very much for your listening. And that's it of my presentation. I'm going to show a very short video regarding to the Waffle Foundation, how the Waffle Foundation is work, and then is your time to ask your question. Let me stop this one and start again. Could you see?
Yes, sir.
Thank you very much. Your time to ask your question.
Yeah.
Thank you for
Thank you so much, sir.
attending.
Thank you. It was a wonderful presentation. Dear students, it's time to interact with our expert speaker. Are there any queries? Yes, Joe Jacob, I can see some queries from the students.
Yes. Am I audible now?
Yes, proceed.
Yes, sir. So thank you so much for the presentation, sir. It was really informative, and I'm sure all of the students loved it. You did cover most of the things related to soil expansion, so I'm sure everybody's already very all clarified on whatever doubts they have. But just in case, once I had a query related to this, once we've built a structure, um, and once we start to see the signs of, let's say, soil expansion, what should we do? Or like example, if an already built structure is an already existing structure, what should be the steps that needs to be taken, and is there like a permanent solution? Um, Mr. Araz, I think you're muted, right?
Okay. Thank you very much for your question. You feel, you mean, for example, you already started your project and then you feel that there's expansive soil. This is depend on your construction process. If the project was already finished, that time you should think about how to prevent your project. And if it is damaged, then you should think about the maintenance, how it will be maintenance, how you can change some parts of your building. For example, there's the very common effect of expansive soil is the partial settlement or the partial crack in some parts of your building. If you feel such a thing as you can maintain it, these parts, not whole building, but you should do some take actions for prevent your project, whole project from the effects of expansive soil. But if you inside the process, I mean the already started but not finished, you should think about the next steps, because the project is started from the steps to the end. But unfortunately, the only thing that we can do for enhance the problems of expansive soil should be in the frame. If you already finished your frame, you are in the finishing process, there is nothing in the finishing process. That time, the only thing that you can do, keep your structure from the water variation. This is the very important point that I pointed, and also I concentrate on this point sometimes, because the water variation is the main reason behind. Therefore, you can do it and keep your project from this. Thank you very much for your.
Thank you so much, sir. There is another question in the panel.
Okay. Okay.
Somebody's asking, is liquefaction effect related to expansive soil?
Liquefaction, no, liquefiable soil. No, this is another problem of problematic soil. Actually, we show some problems. We see dispersive soils, and liquefiable soil is another type of soil. This is not related to expansive soil, because liquefiable soil is the type of soil that lead the water goes through it. What's this mean? For example, the water table is a high rise. It means in the some area there is the high water table, and the land is liquefiable land. I mean the soil is liquefiable. Liquefiable mean there is lots of void ratio that allow the water go through it inside. For example, in the case of earthquake, if there's a strong shaking in that land, I mean the aquifer or the water table also will be shaking, and the water comes out. And that time, those waters make a huge pressure on your structure. In case your structures could not detect these huge pressure, maybe the building may be tilted. This is the liquefiable soil. There is no relation to the expansive soil, but the damage is somehow really close to each other, because both of them make a pressure on the soil, on the foundation, and both try to uplift your foundation. It means the effect is the same. There is a similarity between liquefiable soil and expansive soil, because both have this problem for your foundation. But the state and the structure of the liquefiable soil is somehow different from the structure of mineralogy of the expansive soil.
Thank you so much.
Welcome.
There is one more question in the panel. What is your suggestion for soil expansion in India?
For India, actually, maybe I don't have more information about the India environment, India situation, but there are some main recommendations for every civil engineer to think about the soil stabilization at the first. Why? Because I put it, the first option is soil treatment, because soil treatment is low cost than the structural modification. In India, I think India, because it's a very large area and a large population, there is lots of waste in that country. Therefore, I suggest that use soil stabilization, use the waste material, because the waste material can enhance the soil, and meanwhile, it is a good practice for keeping your environment. I think that the most popular waste material that they already use it in your research is the fly ash. Fly ash is the one of, I think is the very popular, and you have lots of tons of fly ash that can be used, and lime and some materials that can be used. I suggest that soil stabilization is the best option for India, because you have lots of different waste material.
Perfect. Thank you. There is another question. So what type of foundation is most suitable for this type of soil?
Actually, we have lots of different types of foundation. In order to have a choice for the civil engineer, the best one is dip foundation, but it's not that costly. It's a very high cost. That's why we don't recommend the pile foundation for expensive soil. But I think the waffle foundation is the most powerful one, and work is very good, and it is not very costly, because again, you can provide a box inside your foundation by different materials, and such a material that useless, you can use it. And again, this is the environmental concern, and it's very good for the places that high potentiality of expansivity or swelling potentiality. But if there is no high swelling potential, you can use all the different types of foundation, but you should take action with such a prevention and recommendation that we already discussed. Without think about such a technique, is your foundation could not be safe. Otherwise, every foundation can be used, but it depends on the level of expansivity.
All right. Thank you so much, sir. I think that's all the questions right now.
Okay.
Thank you very much.
Yeah, thank you, sir. And I would like to share my views about today's session. Sir, it was a wonderful and excellent session. Thank you so much.
Thank you very much.
Your session was very creative, well organized, and well presented by you, sir. And I'm pretty sure, as the head of the department, I'm really delighted to know that our students have learned many valuable as well as practical ideas about the treatment solutions and challenges associated with expansive soils. So they will definitely adopt it in their career. Thank you so much for the wonderful presentation. Over to you, Jacob.
Thank you.
Yes, now it's time to say vote of thanks by Joe Jacob. Please.
Thank you.
Before we conclude the meeting, it gives me an immense pleasure to deliver the word of thanks to all of the dignitaries present here. Firstly, I would like to thank Mr. Araz Ahmed Hamza for enlightening us on the global practices in civil engineering for the foundation options for its expansive soils in Middle Eastern countries. And I think I speak for everybody when I say it was truly enjoyable and so informative, sir. The 1 hour session did not feel like an hour at all. It felt like it went by way too fast, and it was really an amazing session, and I think I enjoyed it a lot, sir. And I would also like to thank the Department of Civil Engineering, the HOD, Dr. Vandana Devi Kam, and all the faculties involved for organizing this webinar session. And lastly, I would also like to thank my fellow students for making this webinar a grand success. So thank you so much, sir. Thank you for gracing us with your questions, and we hope to have more of you with us.
Thank you, sir.
Thank you.
Thank you
very
so much.
Thank you for you, everyone. Thank you.